Hello everyone, welcome to today's video. So in this today's video we'll be solving the problem number of flowers in full bloom. So this is a hard level question and this is the problem of the day on LeetCode. So let us read the question first. You are given a 0 index 2D integer array flowers where flower of I indicates the start of I and end of I, means the ith flower will be in full bloom from start of I to end of I inclusive. And you are also given a 0 indexed integer array people of size n, where people of I is the time that the ith person will arrive to see the flowers. So there is an integer array people that's been given and that's of size n, and where people of I is the time at which the ith person will come and see the flowers. Okay, and return an integer array answer of size n, where answer of I is the number of peoples that are there, number of flowers that are in full bloom when the ith person arrives. So there are various moments, various time points where people will be coming to visit the flowers, and we need to say that we need to show the output that at the ith moment, at the ith like when an ith person arrives, what is the number of flowers that he will be witnessing to see. Like that is the thing, that is the question. So let us understand in a deep fashion with the help of the very first example that's been given to us. So flowers equal to 1 6 1 6 3 7 and 9 12 and 14 13 4 13. All right, 4 13. So what are these points? So this is the start point, this is the end point of what are the start and end points? This is the start and end point of 0th flower blooming status. Okay, blooming status. So 0th flower or 0th index flower or the very first flower. Okay, so we can even say that 0th index or first flower. Okay, 0th index or first flower. So it blooms at t equal to 1 and ends blooming at t equal to 6. Fine. So this is what he meant. This is the second flower or the first index flower. This is the first index flower, first index or second flower. Okay, anything. So it's just like the terminology that we need to use. So it depends on us. So this is the second index or third flower. Okay, and this is the fourth index or this is the third index or fourth flower. Okay, fourth flower. So these are the time intervals that has been given to us. So from start point to end point, each and individual flower will be there. So let us represent this in the diagram. Okay, so we'll be taking a number line. We'll be taking a number line. So it starts from here, from 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, so from this position, from t equal to 1, okay, from t equal to 1 till t equal to 6. Okay, this is the time interval of first flower. From t equal to 3, let us represent this another color. T equal to 3, from t equal to 3 till t equal to 7. From t equal to 3 to t equal to 7, this is the time interval of second flower. And be using another color. From t equal to 9 till t equal to 12, this is the time interval of third flower. And we'll use other color now, yellow, for t equal to 4, from t equal to 4 t equal to 13. Okay, so this is the time interval of fourth flower. So if we can see now, there is another array that has been given, people array. So what does that mean? People array indicates like this is the time point at which the ith person will come. So what is that people array that has been given? 2 3 7 11. So this means that 0th person, okay, or even it's fine if any person. So a person visits the flowers at t equal to 2 seconds. This indicates at t equal to 3 seconds. This indicates at t equal to 7 seconds. This indicates at t equal to 11 seconds. Okay, so a person visits the flowers at t equal to 2 seconds. So let us see how many flowers were there in the blooming stage at t equal to 2 seconds. So this is t equal to 2. So how many flowers are in the blooming section? There is only one flower. So what is the flower? Only this. All right, so there's no other color to the left of 2. There is only one color to the left of 2. So only one flower is in the blooming stage. So the output would be 1 for the first point, that is t equal to 2. Now come to t equal to 3. So t equal to 3, we have two flowers, this one and this one, right? So if the pink color appears once again, that means that the blooming stage has ended, but it's not appeared for once again. It's a very only one instance of pink is there and only one instance of blue is there. So there are two flowers that are still in the blooming stage. Now come to 2 equal to 3 is done, t equal to 7. Come to t equal to 7. How many flowers are there in the blooming stage? We see that the pink, so-called the pink color has started here and has ended here, so it's gone. And so same is the case with blue. So blue is still in the blooming stage, right? It's still in the blooming stage. It hasn't been completed yet. This means we are at t equal to 7. So at t is equal to 7, it's going to complete, but both inclusive. If we see the question, so from start I to end I inclusive. So inclusive in the sense it is still blooming. All right, it haven't ended. So and there is another color yellow. There is only one instance of it. So in total, this point, this one and this one, there are still in blooming stage. So there are total of two flowers which are in blooming stage. I hope you people are able to understand what I'm trying to convey. And we are done with t is equal to 7. Now come to t equal to 11. So coming to t equal to 11, how many colors are there? So pink has started, pink has ended, so it's gone. Blue has started, blue has ended, it's gone. But yellow has started, but it hasn't been ended. And orange has started, it hasn't been ended before 11. So there are how many flowers? So this flower and this flower. So total of two flowers are still in blooming stage. So we have even completed for t equal to 11. So how many are there? Like this is the output. This is the output array that is expecting us to return, and it matches with this, right? 1 2 2 2 1 2 2 2. So this is how it is. So we just need to identify that by that position, by that time, at that particular time, how many have actually ended. All right, how many have actually ended. So this seemed to be like at least I think few of you might have got an idea. It's a very common sense thing to understand that at any particular point. So how did we approach right now to form the output array? The same technique you will be using. So at any particular time, if I'm analyzing, let us assume I'm analyzing at t equal to 7. So what am I trying to check? I'm seeing two things. What are the two things that I'm seeing? So I'll just erase these things first. So I'll just erase this stuff. So what are the two things that I'm seeing? One thing that I'm seeing is how many have bloomed so far, how many are have bloomed so far, and how many have bloomed so far. This is the first thing I'm seeing. Second thing, how many have completed blooming? Okay, how many have completed blooming? So how many have completed blooming? So blooming so far in the sense it's a like it's still, it may also include the flowers that are still blooming. Okay, or if I need to write this in a much proper fashion, how many are have started blooming? Okay, how many have started blooming? How many have started blooming till this point? Okay, how many have started blooming till this point, and how many have completed blooming till that point? So at that till the point that I'm interested, till the point that I am interested. Okay, so till the point I'm interested, I'll be finding these two things and I'll be subtracting these two, right? How many have started blooming and how many have completed blooming. So for example, when I'm analyzing at t equal to 7, I checked if the pink color has appeared once again. Yes, it has appeared once again. And I've checked blue color has appeared once again. Yes, it's appearing once again. That means that but it's on this t equal to 7 itself. So that means it's still blooming. And yellow has appeared for the very first time before 7, but it hasn't appeared after 7. It hasn't appeared once again before 7. So that means it's still blooming. This is still blooming. Similar is the case with blue. It's still blooming. It is still blooming. But pink, it's completed, right? It's completed. So I'll be subtracting these things. So out of 3 flowers, I'll be subtracting 1. So I'll be 2. This indicates completed. All right. This completed. This indicates started. Okay, this started. So 3 flowers have already started blooming by t equal to 7, and 1 have already completed blooming. Only 2 are still undergoing the process of blooming. So the answer is 2 for t equal to 7. So that's how we are analyzing the things. I hope you people understood. So how do we get this idea? So how do we understand so particular flower is blooming, particular flower have completed blooming? How do we do this? By the flower array that has been given to us. So how do we analyze it? Let us see that now. So I'll be erasing these things. I'll just use the array that has been given. So what is the approach is what we'll see now. How can we do the things? So first thing we understood is what is the procedure or what is the technique, like how are we judging it, how are we able to come to a conclusion regarding the number of flowers that are still blooming, that we have understood. But how do we code it, how do we actually find that, is what we will be doing now. So I'll make two arrays. Start array. So start array indicates the array of like starting times, like the start times of all the flowers, blooming of all the flowers. So it takes the 0th position of all vectors that are there in the flowers. So 1, 3, 4, 9. We'll even sort it. Okay. So make sure once you put in the values, you sort that array. And then end array. Okay. End array is the ending time. It has all the end times of like completing like end times of all the flowers of the blooming states. So you need to even sort this. So 6, 7, 12, 13. All right, 6, 7, 12, 13. So this is the thing. I'll put this yeah, fine. Okay, so I'll just erase this, and I'll even do the same thing with this. I need some space to write. Okay, so I've got the start array, I've got the end array, so I've got the timings. Now let us analyze these things. So people array has been given to us. The very first thing is 2. So 2, where it does it take place in the start array? So if I apply upper bound on 2, okay, upper bound on start array with the target value of 2, upper bound on start array with the target value of 2. So what does that point out? It points out to this particular value. So it gives the index value. So what is the index value that it gives? 1. And what is the value at 1? That is 3. All right. So when I apply the upper bound on the particular value of people, that is 2, I am getting one index 1. So what does that mean? What can we infer from this? We can infer that one flower have already started blooming. So this indicates that, right? So if I apply the upper bound on the particular thing that has been given 2 on the start array, I'll be redirected to the first index, because first index value is just greater than the value that I'm trying to look. This is what I'm trying to find. Okay, trying to find, and I found 3. 3 is at index 1. So this is what I'll be getting. So what is this? This indicates that there is one flower that have already started blooming. So I've got the very first thing that is required. So I've got this particular thing. I've got an answer to this question. Let me indicate this with another color. I've got an answer to this question. Now I need to find how many have completed blooming, right? How many have completed blooming? And for that I need to check the end array. For inferring or to get an idea of how many flowers have started blooming, I'll be using the start array. But to find how many have finished their blooming, I'll be using the end array. All right. So when we are applying lower bound on end array with the value 2. So it indicates this particular position, right? Because lower bound tells that lower bound gives the value or index at that element that is greater than or equal to 2. Because there is no 2 in the end array, it will be pointing to this. And what is the value? What is this? This is basically nothing but 0th index, right? So it gives the index of that element which is just greater than or equal to the value that we are trying to find. We are trying to find 2. So we'll be getting this particular index. So this index 0, what does that denote? So this denotes that there is no flower, like 0 flowers have completed blooming, right? 0 flowers have completed blooming, isn't it? So 0 flowers have completed blooming. If this is exactly 2, let us assume this is exactly 2. So even at the end position, we can assume that because it's told that it's inclusive, even if it's end position, we can say that there's that is 0 flowers have completed blooming, because even at the end position the flowers will still bloom. So lower bound gives you so this is 6. So lower bound of a particular value you're trying to find gives the index of that element that is just greater than or equal to. So in both of the cases we can say that 0 flowers have completed blooming. So from if we just subtract these two, so I've got even answer to this particular question, right? I've got answer to this particular question. So how many flowers are there that are still in the blooming stage? 1 minus 0, which is equal to 1. So that is the output, right? 1. So 1 flowers is still in the blooming stage. So now we have got the answer for the very first for 2. Now let us examine on 3. Okay, now let us examine on 3. So I'll just erase these things. So lower bound so yeah, upper bound and lower bound is what we are trying to deal. Okay, this is what we are trying to use. So upper bound, and now this time it's 3. Now it's this time it's 3. Okay, this is also on 3. So upper bound of a start array on 3 gives me this particular value, gives me index value as 2, because upper bound will always give the index of that element which is just greater than the target that we are trying to find. So this is the target, but what's just greater than 3? This. So it will be giving this index. So this is what it's going to give. And lower bound on 3, it's going to give that particular value which is greater than or equal to the target. We are looking out for 3. There is no 3, but there is 6. So it will be giving this particular index. So 0. So 2 minus 0. So 2 minus 0, which is equal to 2. So that means there are 2 flats. So what does this indicate? When upper bound gives the value as 2, what does that indicate? There are 2 flats that have started blooming already, that have started blooming already. Okay, blooming already. And how many flowers that have completed blooming? 0 flowers. 0 flowers. Okay, 0 flowers have completed. Okay, completed blooming. So there is no flower that have completed blooming. So whatever has been started, it's still blooming. So you can even infer that from this particular thing. So when we are at time 3, so we find that there is particular pink element, okay, and but blue element. Both of them have started. There is no repetitive of pink. There is no second occurrence of pink or second occurrence of blue by t equal to 3. They are occurring for the very first time. So we can infer that 2 minus 0 equal to 2, it matches. Similar is the case. We can even work on 7. So when it's 7, okay, let me erase this stuff once again. When it's 7, so 7, what does that 7 indicate? So upper bound on 7, so let us write this here. So upper bound of 7 and lower bound of 7. So upper bound of 7, what does that indicate now? And here on the start array, it gives what does it give? So it gives the answer as 0, 1, 2, 3, right? Why does it give 3? Because 7 upper bound, when you're trying to apply upper bound on 7, it's going to give that index that of that element which is just greater than 7. So 9 is just greater than 7, and what is that index? 3. And lower bound on 7 gives that particular index of that element which is greater than or equal to 7. So here we have a 7, so we want to get 1. So what is the difference? 3 minus 1, which is equal to 2. So there are 2 flowers. So what can we infer? So this 3 indicates that 3 flowers have already started blooming. 3 flowers have already started blooming, by t equal to 7 seconds. All right, so if you can even check here, when at t equal to 7, there is pink, there is blue, there is yellow. 3 flowers have already started blooming. And what does this 1 indicate? 1 flower completed blooming. 1 flower completed blooming. Okay, 1 flower completed blooming. You can even check here. So pink has occurred for twice, so that means it has started, it has completed. But blue, it is still going on. Yellow, it's still going on. So that's the reason there are 2 flowers. So that's the reason we have to. Similarly, you can even check it for 11. All right, so this is how you do it. So we need to answer 2 questions. So what is the what are the flowers, like how many flowers have started blooming by that point, and how many flowers have completed that blooming. So if we just subtract these 2 values, we'll be getting the required answer. So that's how it's done. So we are using the concepts of upper bound and lower bound to find the required answer. All right, so this is the technique. And another brute force technique to solve this question is, so the brute force technique, like it will be the test cases will pass till 32 out of 52. So what is the brute force technique? Brute force technique is using the prefix sum array technique. Okay, prefix sum array technique, or this can even be told as difference array. Okay, difference array technique. Okay, difference array technique. You can search on YouTube. There are superb videos on this technique. Learn this technique and apply on this problem. Learning this technique is just time consuming. It's not like you need to spend a lot of time. It's very easy. Once you learn the technique, you'll be able to apply it very easily, and you'll be finding that only 32 will be passed out of 52. I'm not putting that code because of the time constraints of this video and all. So this is the optimal technique. What is the optimal technique? Answering to the 2 questions: how many have started blooming, how many have completed blooming, till that point that I'm interested. Okay, so that's what. So we'll be going through the code now. So vector in start time and end time, 2 vectors to store the start time and end time. So I've stored here. So start time dot pushback of flowers of I of 0. This pushes the 0 like the start time, and this pushes the end time. And now we need to sort them. Okay, we are trying to apply upper bound and let me write it clearly. Upper bound and lower bound. Okay, remember these two are implementations of binary search, right? Binary search. And for this thing, we need our array to be sorted. Okay, we need our array to be sorted. If not, these things doesn't work out. And now vector of int of answer, that's required answer. So int I equal to 0, I less than and I plus plus. I people are, n people are there. Okay, n people are there. So int started blooming. This this int denotes number of flowers that have already started blooming, and that's basically nothing but upper bound of start time begin, start time dot end, and people of I minus start time bloom. This gives the index. Okay, index of the element that is just greater than, people of I. Okay, people of I. So this indicates the number of flowers already started blooming. Number of flowers already started blooming. Okay, number of flowers already started blooming. This is what it's going to give. And what does this give? Stop blooming. This gives number of flowers stop blooming, number of flowers completed. Okay, completed blooming. Okay, completed blooming. So that is what the second one, stop blooming, gives. And answer of I is basically nothing but the difference. Okay, difference. So and written answer. So that's it. So this is how we will be doing for each and every n. So I hope you people understood. And what is the time complexity? So if we see, if we actually analyze this properly, so we are sorting. The very first operation is sorting start time and end time. Okay, start time and end time. Okay, and let us assume both of these have a size of n. Then this takes O of n log n. Okay, n log n. And second one, what are we trying to do? Second one, we are applying the binary search. Okay, the binary search on the start time and end time. And let us assume this is for again people size time. So people, if I assume the people array is of size m, then for m times we are doing log of n. Okay, m times we are doing log of n. This is because of upper bound and lower bound. Okay, upper bound and lower bound. So this completely takes O of m plus n log n. Okay, so O of m plus n log n, this is the time complexity, and space complexity is O of m. So if I assume, like, what am I trying to do? People size array is what I'm taking. If it is m, then O of m. So this is how this is the time and space and complexity analysis. I hope you people understood what are we trying to do. It's a very good question of binary search. We are using the concepts of upper bound and lower bound, which is very, very important. And the basic sense is the basic common sense is what we are trying to use here in terms of coding. All right, so how many have started blooming and how many have completed blooming? If we just subtract this, we'll be getting the answer of number of flowers that are still in the blooming stage. That's it. That's a pretty obvious thing that we are trying to use here. And you can even check out this code. I'll even try to submit it and check for your people reference. Okay, I hope, accepted, fine. So I hope you people understood the question. For your information, the codes in all the 3 languages have been uploaded in the GitHub repository, and that link has been given in the description. Do check it out. Okay, so thank you for watching, guys. Stay tuned.